Pseudo multivariate calculus, we will proceed the discussion in. Pseudo multivariate calculus, where we are continuing the discussion. Pseudo multivariate calculus. Can we solve a can we solve a mathematical problem? Can we solve a mathematical problem through simple multiplication, division, subtraction, and addition? If we see repeated addition, then we can substitute by integral calculus. If we see multiplication, then we can substitute it by integral calculus. If we see repeated subtraction or division, then we can substitute it by differentiation. That's it. That's it. Okay, then what is class here? The class here is to find the division and multiplication. Breaking anything into division and multiplication, that is an art. If someone is able to do it, then at least vector and calculus is no more difficult entity for him or her. Okay, that is the scenario, how nice it is. Then can you give any example like that? We have given this, at least finding the length vector. Many times we have example given like that. What is the length vector? Okay, like I'll face it. So like if someone has a consider this is x-axis, and there is a line. If this line is connecting point origin and point x comma y, then what is this length of the line? Through Pythagoras theorem, the length of the line is x square plus y square square root. That is same as magnitude of a vector xi plus yj. Means if I represent any line connecting two points as a vector, calculating the magnitude of the vector will give the length of the line. Is it really hold true for a curved line? If curved line attaches origin point, this is origin, and point x comma y here, if I represent this as a vector, then will it, calculating the magnitude of the vector, will it give the length of this curved line? Certainly. This is pseudo. Pseudo means whatever we are saying, it will not be false. We are not going to change it. Okay, so what is the vector representation of this curved line from origin to x comma y? Vector representation of any two point origin and x comma y is xi plus yj. In that way, if this is the x, if this point is x comma xi plus yj from origin, if I connect like this, okay, then this is called position vector. What is the vector representation what is vector representation of two points? One is origin and one is x comma y. Then it is then it is then it is xi plus yj. But if I find magnitude of xi plus yj, it will give length of this vector, not the curve vector. Then we saw that curve vector has y by x, y by x, y. Every moment y by x is different. Whereas for the straight line, if I take a straight line, then y by x, everywhere it is same. Means if I want to represent a curved line through a vector, then y by x should be there because that is variable. What is the current vector representation that we are talking? Xi plus yj. Means x and y are changing. But here in the curve, y by x is changing also. In that sense, we took out x from here and it becomes I plus y by xj bracket close into x. Okay, means if someone takes out x from xi plus yj, it becomes I plus y by xj bracket close into x. Okay, then division becomes differentiation, multiplication becomes integration. In that way, it becomes I plus dy by dxj bracket close into dx. Okay, if that is the scenario, is it the vector representation of a curved line? Certainly. It started from xi plus yj only, but later it become I plus y by xj. Y by x I need. I plus y by xj, bracket close into x. Later it become I plus dy by dxj into dx. This is the representation of a curved line. Anyway, we are in a phase of finding the area vector. Why you need area vector? We need area vector because we want to find the surface area of this. We are trying to validate that our approach is right or not. Calculating the length vector as I plus dy by dxj, bracket close into dx. This is what we are bringing into concept. If I need to represent any line, I can just write there I plus dy by dxj, bracket close into dx. Simple. Anywhere. Okay. Like if I need work done, then force vector dot displacement vector is the work done. Force vector is all right. It will be written in the question. Dot displacement vector, just place there I plus dy by dxj, bracket close into dx. Okay, but no. But it is written in the book that work done is force vector dot d of position vector. What is position vector? Position vector is xi plus yj. Differentiation of position vector is the displacement vector. This proves that in book it is written that work done is force vector dot d of position vector. This means that if any item is moving along this line, any item is moving along this line under a particular force, then force vector dot position vector of this line, d of position vector of this line, is the energy calculation. What is position vector? If this is origin, then this is position vector, where this point is x comma y. Position vector keeping origin one point exactly at the origin, this will start moving like this. Okay, and it will become x comma y will start sliding like this. So position vector will start moving like this. Okay, in that sense, differentiation of position vector will give the exact line vector. If I differentiate this position vector at this point, it will give me tangent at this point. So everywhere tangent at a line is also a line vector. So in the modern way of writing this is force vector dot d of position vector is the network done. Means d of position vector is the line vector. Position vector is xi plus yj. D of xi plus yj is dxi plus dyj dot force vector. As per our calculation, the force vector dot displacement vector is the work done. Displacement vector is I plus dy by dxj into dx. If someone breaks it, actually it becomes dxi plus dyj only. So it validates. Now we will validate our length vector in terms of area vector. What is the current area calculation? We will go by the flux calculation. Flux means if I have a liquid, flux means if I have a liquid is flowing like this and it is passing this surface, and from this surface, how much is the fluid coming out per second? How much is the weight of the fluid that is coming out? Volume of the fluid is coming out per second. Consider there is a liquid and it is flowing at 10 meter per second. 10 meter per second, and it is hitting a surface which is 1 meter square, or say 2 meter square. Then 10 into 2, 20 meter cube of the liquid will come out from here per second. That is called flux. Velocity into surface area is the net amount volume of the liquid that will come out. If liquid is not exactly hitting the surface, means surface vector will be perpendicular to the surface. Surface vector is not the line vector that will be along the surface. It will be perpendicular to the surface. So if liquid vector and surface vector they makes zero angle, we can directly multiply liquid vector velocity with the surface vector. In that sense, liquid velocity dot product with the area vector. If dot means if angle is zero, If angle is 0, means directly I can multiply, or or there will be cos theta. Anyway, now we will see both analogy of calculating this. So here we need velocity vector is given dot product with the area vector. How to find area vector? One we will go through the modern way, and one we will go with our displacement vector concept, that is I plus dy by dx j bracket close into dx, this fundamental, and see if both are same. The way we saw that work done is same, here flux should also be same. Now we will go, let's go by the our fundamental first. So our fundamental says that if consider how to find area vector. Consider I'm trying to find area vector of very awkward shape that is like this. Consider this is a sphere for simplicity. Consider this is a sphere. What is area vector of this sphere? Everywhere area vector is different. See, area vector is like this. Here area vector, everywhere area vector is different. To find the area vector of complex shape as per the pseudo mathematics, we go with the simplest case. Simplest case is the rectangle. How to find area of a rectangle is width into length is area of the rectangle. If I say this is origin, this point is x2, y2, and this point is x1, y1, then x1 square plus y1 square root is one side, and one is x2 square plus y2 square root. One is magnitude of a vector, that is xi plus yj. One is magnitude of a vector x2i plus y2j. x1i I plus x1 y1j, x2i plus y2j. Okay, if these two are the magnitude of these two vector multiplication is the area. Or we can say, if I say this is a vector and this is b vector, then magnitude of a vector and magnitude of b vector will give the area. If this angle is not 90-degree, then a vector cross b vector, a vector cross b vector, and then calculating the magnitude of this cross will actually, it will give the area vector. Area a cross b, whatever comes, it will bring a new vector. Calculating the magnitude of this new vector, calculating magnitude of this new vector will give the area vector, will give the area. Or calculating the a cross b as a new vector will be area vector. Now calculate the magnitude of area vector to get the area, or calculate the unit vector of area vector to get the direction, whatever is required. In that way, a, a vector cross b vector is the surface area. Now consider that this surface, this is the flat surface area we are talking, and it becomes a curved surface area. Then our a vector become a vector representation of a curved line, and b vector become vector representation of a curved line. Still, area vector is A cross B only. This is pseudo mathematics. Area vector is A cross B only, where A vector represents a curved line vector and B vector represents a curved line vector. In that sense, what is A vector, that is curved line vector? A vector is, if I consider it as along x axis and B vector is along y axis, then A vector is xi plus yj. B vector is also xi plus yj, or someone can say x1i plus y1j. This is what where we had started. And B vector is x2i plus y2j. Now from one I'll take out x and one I'll take out y. Then it one becomes I plus dy by dxj into dx, cross product with dx by dy plus j bracket close into dy. If I take all three z also, then it is I plus dy by dxj plus dz by dxk bracket close into dx, cross product with dx by dy plus j plus dz by dy k bracket close into dy. So this is the net area of a curve where one side is represented as I plus dy by dxj plus dz by dxk and bracket close into dx. Cross product with dx by dy plus j plus dz by dyk bracket close into dy. Okay, now if I talk about the surface area of any curved surface like a sphere kind of scenario, then what is the area vector? In the sphere, we have to find two curved lines for which we will calculate the cross product. If I try to get the curved line for this, I'll bisect it in xz plane and orthogonal in yz plane. If I make two bisections, one in xz plane and one in yz plane, then xz plane will give a circle. Xz plane will give a circle and yz plane will give a circle. This is a curved line. This is a curved line. If I do cross product of these two curved lines, again we will get the surface area vector. I need cross product of two lines. If I have a surface, then two line means one side of the surface and another side of the surface. If I do cross product of these two, I'll get the surface area vector. So any for the sphere, for the sphere, okay, for the sphere, if I cut it in xz plane and if I cut it in yz plane, then xz plane gives a curve and yz plane gives a curve. Okay, in that way, xz plane curve I have to represent it as a xz plane curve. I have to represent it as a our length vector and yz plane I have to represent at y because both are in orthogonal plane. So they will represent the two curved line for the surface. If I take this surface any moment, if I take this surface any moment, if I take this surface any moment, okay, if I take this surface, okay, if I take this surface any moment, then surface will be like this, where one curved line and another curved line. One curved line is in xz plane and another curved line in yz plane. Now same fundamental we will apply in xz plane. In xz plane, we have a vector called I plus dy by dx j plus dz by dxk bracket close into dx cross product with the curved line in yz plane, that is dx by dyi plus j plus dz by dyk bracket close into dy. If I do cross product of these two, it will give me the surface area vector. Okay, now if I cut in xz plane, then here everywhere y is same. Y is not variable. Z is variable over x, but y is same. Means dy by dx is 0. If I cut in yz plane, then everywhere x is same. So dx by dy is 0. In that sense, the surface area vector is I plus dz by dxj k. I plus dz by dxk bracket close into dx cross product with j plus dz by dyk bracket close into dy. If I do the cross product of these two, then it becomes minus dz by dxi minus dz by dyj plus k bracket close dx dy. This is the area vector. This is called generic area vector where xy plane is variable and z is dependent upon it. Z is dependent and x axis and y axis is independent. In that case, area vector through our way, area vector through our methodology is is minus dz by dxi minus dz by dyj plus k bracket close into dx dy. If I am trying to find the flux, then flux vector, I'm sorry, velocity vector dot product with the area vector is the net flux. If flux vector is, I'm sorry, velocity vector is v1i plus v2j plus v3k, then v1i plus v2k plus I'm sorry, v1i plus v2j plus v3k dot product with in a bracket minus dz by dxi minus dz by dyj plus k bracket close dx dy, or minus dz by dx, I'm sorry, or dx dy into minus dz by dx, I'm sorry, I'm really sorry. So the net flux calculation would be v1I plus v2j plus v3k. These are the full velocity vector dot product with with dx dy into minus dz by dxi plus dx dy into minus dz by dyj plus dx dyk. This is area vector through our fundamental. What is written in the book? In book it is written as that the net area vector, the net flux is velocity vector dot d of position vector, same as in the work done calculation. Please watch our previous video. Same as in the work done calculation. What is the work done calculation? Is force vector dot d of position vector. What is work done? Force vector dot displacement vector is the work done. Please watch our previous two videos. Okay, force vector dot displacement vector is the work done. Displacement vector is derivative of position vector. Okay, if I have a line vector, if I have a curve line, and then I have a position vector, if I have a curve line, and if I have a position vector, then differentiation of this position vector any moment give the curve vector. This is what we have seen, I believe, many times. Okay, it was here only. Okay, okay. Okay, what we found is if any item is sliding like this along this line, then force against any force vector, any item is sliding along the line, then force vector dot with this is displacement vector. Okay, doesn't look like a vector, but this is displacement vector. If someone does the dot product, then it will give the net work done. Now, if I consider this point as origin, then from origin, if I draw a position vector, from origin, if I draw the position vector at any point, differentiation of this position vector will give the tangent vector at that point. Differentiation of position vector will give tangent vector at that point. If we see in the book right now, the book in book, what is available in the book, it is available that the net flux is velocity vector dot product with the area vector. What is area vector is d of position vector of an area. If I take this if I take this sphere, consider this is a sphere and it is centered at the origin. This is a sphere and it is centered at the origin. If it is centered at the origin, consider that any point P here from the center. Center at origin means center of this sphere is 0, 0, 0. From 0, 0, 0 at point P, if I draw a line, then that is called position vector or position vector to an area. Okay, if I have position vector, if I have a position vector, if this is origin and this is point P, then if I connect like this position vector of a curve, if I do d of P, derivative of P, then it will give tangent at that point, tangent vector at that point. If I combine all the tangent vector, then it becomes a length vector. Similarly, if I have a point P here, if I have a point P here, and from center, if I connect a line to point P represent here area position vector. If this is the position vector of an area, if I do d of P, differentiation of P, then it will give the area vector. So velocity vector dot d of position vector of an area will give the area vector. Area vector is perpendicular to the surface. Okay, through modern way, we have found that through modern way, we have found that the net flux is velocity vector dot d of position vector. Okay, d of position vector. What is position vector? Position vector is xi plus yj plus zk. What is d of position vector? Nothing. Just differentiation. dxi plus dyj plus dzk. Anyway, d of position vector is the area vector. Okay, P is the position vector. Derivative of position vector is the area vector. It is in synergy of derivative of position vector to a line, to a curve, is the is the is the is the is the length vector. If this is the position vector of a line, then derivative of position vector is the tangent at the line. That is also called the length vector. Similarly, if I have a position vector to a surface, then derivative of this position vector will be surface vector. In that sense, d of p. D of p can be written as d of p divided by d of xy plane into d of xy plane. Makes sense? What is d of xy plane? What is d of xy plane? D of P divided by D of xy plane into D of xy plane. A change in position vector with one unit change in xy plane into D of xy plane. Now we are going through a modern way. D of position vector D of P is same as D of P divided by D of xy into D of xy. That is change in position vector per unit change in xy plane. If I say dp by dx, then per unit change in x-axis means single length. If I say d of xy plane means area. If there is one unit of change in xy plane, then how many unit of change I see in p? That is dp by dxy plane. dp by dxy plane is how much position vector, surface area position vector changes when we have one unit of area change on the xy plane, dp by dxy plane into dxy plane. Now to understand that, let's consider that I have a xy plane. Okay, now let's consider I have a xy plane and there is a surface over xy plane. Okay, if there is a surface over xy plane, consider this is the surface over xy plane. And I have any point here at x comma y. Consider any point here in x comma y. If I go top in xy comma y, it hits the surface at point P, that is position vector. From there, if I make a dxy, that is the one unit change, that is the delta x delta y unit change along xy plane. How much the position vector is changing? Makes sense? How much is the area that position vector p is making in the change? Makes sense? In a way that if I have any point here on the x-axis at x comma y, if I move along x-axis at x plus delta x and along y-axis if I move at y plus delta y, then we will make a rectangle where one point is x comma y and another point is x plus delta x comma y plus delta y. This is a rectangle. One is x comma y and another corner is x plus delta x comma y plus delta y. Means we made a change of delta x into delta y on the xy plane. That is dxy plane. Dp by dx means if I make one unit of area change in xy plane, how many of area change in position vector I see? Now I am making derivative delta x and delta y unit of area change on xy plane. For x comma y, if I see the surface, then it hits here. Consider it hits here. For x comma x plus delta x comma y plus delta y, it will hit here. Okay. Now for x plus delta x comma y, it will hit here. For this is p, that is x comma y on the surface. So this is x comma y comma z. So position vector from origin is p. Now for the point that is x plus delta x comma y, it will move another point. Consider that is p1. Then that p1 is x plus delta x comma y plus new z. Now, if I move this direction, the new point is y plus x comma y plus delta y into new z. Now, how much is the area change I see here when I made area change on xy plane, that is delta x delta y, that is exactly dp by dxy plane. To calculate the area change here, on the xy plane, I made two changes. One point was x comma y. For that corresponding point was p here. X comma y, I moved along x axis and one point become x plus delta x comma y. And I move along y axis, another point become x comma y plus delta y. One is x comma y, one is x plus delta x comma y. One is x comma y plus delta y, and one corner point is x plus delta x comma y plus delta y. Now if I see the point p here, the point p, it will go to another point, that is x plus delta x comma y plus mu z, and from this it will go to another point, that is x comma y plus delta y comma comma another z. If I do cross product of these two vectors, if I consider this as a vector and this as a vector, so if this point is p, one vector is p1 minus p and another vector is p2 minus p. If I do cross product of these two vectors, it will give the surface area, that is exactly dp by dxy plane. dp by dxy means per unit change in xy brings how many unit change in position vector. Now per unit xy, instead of per unit change, I am making delta x delta y change. In that sense, I'll see how much unit of change that is seen in the position vector. If I divide, then exactly I will get per unit change in the xy plane, how many units is happening. For delta x delta y change, if I get this much change in position vector, then if I divide, per unit I will get. Now what is I am getting here? What is this point P? Point P is x comma y comma z. Now what is new point P1? That is x plus delta x comma y comma new z. That is, if z is function over x and y, then it is f x plus delta x comma y. Now if I differentiate these two, it will give me this vector, that is x plus delta x minus xi plus y minus yj plus fx plus delta x comma y minus fxy k. Okay, so this p minus, so dp by dxy we are saying, right? dp by dxy is p1 cross p2 divided by delta x delta y. This is what dp by dxy plane actually it means. P1 is delta xi plus fx plus delta x comma y minus fxy k. J is gone by delta x, by delta, I'm sorry, that is numerator cross. If I say p to p2, then it will be in similar to that, it will be delta yj plus fx comma y plus delta y minus fxy k. Okay, so the cross product of P1 and P2 will become delta xi plus fx plus delta x comma y minus fxyk. Cross product with delta yj plus fx comma y plus delta y minus fxyk whole divided by delta x into delta y. Delta x I can keep this side of the cross product. After it is a product, and delta y I can keep that side. Then it becomes I plus fx plus delta x comma y minus fxy by delta x k cross product j plus fx comma y plus delta y minus fxy by delta y k. Okay, if that is the case, then the first one is exactly case of I plus fx plus delta x comma y minus fxy by delta x is nothing but dz by dx. Fx plus delta x comma y minus fxy by delta x, where z is fxy. That is exactly dfxy by dx. What is dfxy by dx? That is fx plus delta x comma y minus fxy by delta x. So dfxy by dx, fxy is z, dz by dx, k. It becomes I plus dz by dx k, cross product j plus dz by dy k. Okay, now someone has to do cross product of these two, I plus dz by dx k, cross product j plus dz by dy k, bracket close into dxy plane, that is delta x delta y dx dy. Exactly same what we had brought. If someone does it, then area vector through new way, that is the d of position vector, will come as minus dz by dxi minus dz by dyj plus k bracket close into dx dy. Okay, this is not the end of the story. We will proceed on this. Okay, with the other coordinate system also. Please do not mind supporting us. Plus 91 is the India country code 9483160610 is the telephone number. Plus 91 is the India country code 9483160610 is the telephone number. Means whatever we started with the pseudo multivariable calculus area vector and whatever right now it is available, both are exactly same. Okay, we will see more towards it.